Hi, my name is Arbil Lopez, and today I'll be talking about this anionic iron 2 complex and what about its molecular orbital diagram explains its intense blue color. So we can consider the first coordination sphere in octahedral symmetry when constructing the sigma-only molecular orbital diagram. So that's the iron, the 3 oxygens, and the nitrogens of these benzoyl cyanoxime ligands, which are in their nitroso form as shown here. And overall, we'll get symmetry overlap between the iron atomic orbitals and the nitrogen and oxygen sulks to give 3 sets of bonding orbitals, 3 sets of antibonding orbitals, and this 1 set of non-bonding orbitals. And purely for clarity, I've used the scale 1 e sigma equals 1 electron volt here. So the d electrons sit in this T2G non-bonding set, and 3 units of e sigma above that, we have an empty EG set. Now, when we consider pi donors and acceptors, this complex is not really octahedral. So we'll have filled donating p orbitals on the oxygens, but we'll also have empty pi star orbitals on the nitrogens of these nitroso groups. But we can use descent and symmetry to do the pi analysis and use the point group C3V. So it is important to note that when we used octahedral symmetry, the z-axis was the C4 axis, but in C3V symmetry, the z-axis is the C3 axis. So we're going to have to rearrange some d orbital parentage labels. In octahedral symmetry, the z squared and the x squared minus y squared orbitals interact with the ligands. But when we switch the z-axis to the C3 axis, it's actually the xz and the yz orbitals that interact with the ligands, and the x squared minus y squared, z squared, and xy orbitals that are unperturbed. So now we can mix our pi acceptors from the nitroso groups and our oxygen pi donors with the sigma-only C3V diagram. And it can be argued that the pi donors and pi acceptors, which are trans to each other, will have a canceling energy effect on the E and A symmetry non-bonding orbitals with which they mix. So the non-bonding orbitals will be raised by 1 e sigma by the donor interactions, but lowered by 1 e sigma by the acceptor interactions. So overall, we have more or less negligible change in the d-splitting part of this diagram. But what we do get are bonding orbitals from the ligands lowered by 1 e sigma and antibonding orbitals raised by 1 e sigma. And it is the promotion of a d orbital electron from these non-bonding orbitals, and denoted by the arrow here in red, to the empty high energy ligand-derived antibonding orbital up here that gives a metal to ligand charge transfer, which is responsible for the deep blue color of this complex, absorbing around 590 nanometers.